So Jill, this is called a chi-square test for independence, and it's similar to the chi-square goodness of fit that test that we were working on earlier tonight, but it can be also very different. Whereas when you are dealing with a chi-square goodness of fit, you determine your expected counts by taking n times p. In a chi-square test for independence, like the one that's displayed here, you find your expected counts in a different way. What you do is you take the row total times the column total and divide by the total of all. So let's say, for instance, that we wanted to determine the expected counts for the cell that is in row A1, B1. We would have to, that would be this cell right here that I've circled in blue. We would have to take the row total times the column total and divide by the total of all. So again, for that cell in A1, B1, our row total would be 156 times our column total would be 135. Divide by the total of all. I added them up, and that was 443. That would give me the expected counts for just that cell. We would have to do this 8 more times for the other 8 cells in this table. So this is a rather tedious calculation to need to do by hand. But in our case here, our expected number in row 1, column 1 would be about 47.54. Now just to check, give you a couple more. Row 2, which is labeled A2, column 1, your expected counts would be equal to 57.291. Give you one more. Say we're in row 3, A3, column 1, our expected count would be equal to 30.169-ish. And we'd have to continue to do that for the remaining 6 cells. Then the calculations that we do to get the chi-square are the same as they are for the goodness of fit. Now we have 8 observed counts. We will have calculated 8 expected counts. We'll use our observed minus expected quantity squared divided by expected to get our chi-square, and then use our chi-square table to get a critical value, or our chi-square CDF to get a p-value, like we did with goodness of fit. One other thing that's different about this chi-square test for independence is the number of degrees of freedom. The number of degrees of freedom in a chi-square test for independence is found by taking the number of rows minus 1 and multiplying columns minus 1. So we have 3 rows, 3 minus 1 is 2. We have 3 columns, 3 minus 1 is 2. So our degrees of freedom will be 2 times 2, or 4. Let me know if you have further questions. By the number of